Hello everybody, it's grade 9 math. This is our similarities unit. This is video lesson number 2 on similar polygons and special emphasis on triangles. So when one polygon is an enlargement or a reduction of another polygon, we say the polygons are similar. Okay, so that's the key word, similar. Now that's a pretty specific word because it means special things. So when we say similar, we don't mean kind of looks like the other one. Like, for example, Darth Vader here, he kind of looks real cool. And the cartoon guy, well, maybe cooler. I don't know. You know, they're the best movie bad guys that I ever known. Anyway, similar means something about corresponding angles and corresponding sides. So when we say similar, we mean that they have to be equal. So when we say a similar arrow, like this guy, and if it has 100 degrees at that point, it also has to have 100 degrees at the corresponding point. Now, it doesn't mean the sides have to be the same because that would just be a duplicate, but it has to be similar. What that means is proportional. Proportional means they go up or down by the same amount. So for example, here, this length is 10 inches. The corresponding length on the other one is 5. Now that's not the same, it's half the size. Okay, so if this size here is 3, then the other half would have to be 6. Ooh, let me change to a pencil. That's gonna be better here. Yeah, change to a 6. So if the angles are the same and the sides are proportional, then they're similar. And that's really good. Now, can just one angle be the same? No. What we want to do is we want to make sure that we have at least 2 corresponding angles are being the same. All right? Good. So if they're similar, angles are the same, sides are proportional. So we can use that idea about similarity to get a lot of information from situations. Now, we also use it with triangles because that's, spoiler alert, really how trigonometry works. So this is like the baby steps for trigonometry. Here are the 3 most common similar triangle problems. Shadow triangles, where we take an indirect measurement. So let's say we want the height of this tree, but we can't get up there with a tape measure, and there's not a ladder tall enough, and who would want to climb up a ladder that way? But if we know something about the height of the guy and his shadow, and we know something about the shadow from the tree, maybe we can figure out the height. So we call those shadow triangles because we can take a related triangle, and because it's similar, find a missing height. All right. Another one is called a nested triangle. And nested triangles are basically where one triangle is hidden on the inside of another triangle, and they both share a common vertex there. All right. Now, then there's joined triangles. And joined triangles are where we're basically taking one triangle, and it might be flipped, or but anyway, they're going to share a common vertex as well. But in this case, we've got equal angles because when 2 straight lines cross, the angles they make, opposite angles are equal. Okay. So each of these pictures reflects situations where we can use what we know about similar triangles to find a missing length. And it's especially easy if we use it, you got it, amazing Dr. Z. So let's go back and solve these problems, but we have to keep in mind that amazing Dr. Z only works if we remember to compare similar parts to similar parts. So that means corresponding parts to corresponding parts. Okay, so here we're going to do this first one, the shadow triangles. So we've got a fella, he's 5 feet tall, and his shadow is 7 feet. And we're going to say that's similar to the other triangle because they have a similar angle here and a similar angle here, and they both have a similar 90-degree angle right there, so they qualify. So we don't know how tall the tree is, so we're just going to make that an X. But we do know the length of the tree shadow is 14. Now, a lot of kids would say, hey, Mr. Chambers, it's just going from 7 to 14. It's doubling. So let's just go 5 and double it and say it's 10. And yes, you're right, we could. But I'm going to use Amazing Dr. Z just to show that it works. Because like with the nested triangles, it can get a little more complicated, and the numbers might not be that easy just to see for themselves. So with Amazing Dr. Z, we always start at the X, zip, 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 make a nice Z pattern. We're going to multiply the corners, so we're going to say X is equal to 5 times 14, divide by 7. So 5 times 14 is 70, divide by 7, and it's 10. So even though we could see that 5 was going to double to 10 anyway, it still works out, which is pretty good. Okay, now let's go to the nested triangles here. So we're going to keep this family together because they belong together. They're parts of the same triangle. So we'll go 1.8 meters and 6. Now, it doesn't matter which one is on top and which one's on the bottom. It basically matters that if the height of the guy is on top, we need the height of the cell phone tower on top. Okay, so let's just put an X there because we don't know how big it is. But we do know the length is 60 meters. Okay, well, what do? Well, Amazing Dr. Z, that's what we do. It's always what we do. Zip, zip, zip. So we'll go X is equal to 1.8 times 60 divide by 6. So if we were 1.8 times 60 divide by 6, we'll get 108 divide by 6. Whoops. Sorry, folks. That looks pretty crappy. 108 divided by 6, and we're going to get 18 meters. There. So that's an indirect measurement. Sounds good. Well, I mean, it's pretty good. Okay, now let's take a look at this joined triangles. So basically, all I want to see here is if I've got that angle there and its corresponding angle over here, then if I'm going up from that angle to get my 20, then I'm going to go this way from the angle to get its measurement. So we're going to have 20 over D, letter D. It's just a letter that's already on there instead of X. And we'll have corresponding with that 20 will be 36. So we better put it on the top. And then the distance is 45. Okay, so what do? Absolutely Amazing Dr. Z. So we'll go D is equal to 45 times 20 divide by 36. So that gives us 900 divide by 36, and that's going to be 25 meters. There you go. So in each case, you're just setting up corresponding sides to corresponding sides. Amazing Dr. Z. Super easy. So that gives you guys the ability to do a little bit of work now, okay? So I'd like you to work in your textbooks. I'd like you to go to page 349 and 351 and do those questions. And guess what? When you do them, you can check your answers in the back. If you have any troubles, just send me a message on Teams and we'll get it worked out. But already you're smarter than you were before you started watching this video. And that is my gift to you. See you in the next one.